Hello and welcome back for another VMK in the Math series. In this VMK, I'll be showing you how to create a relationship between one item and another. And using this relationship, we'll be able to change the range of relationship A with respect to relationship B. And I'll show you how this works. If you're finding my videos helpful and you'd like to support my website, you can do so by clicking on the PayPal icon or any of the Google ads found on the side. Okay, let's take a look at what we have here. Let's say you have some numbers that range between -5 and +1. I'll label that as the input. And I want to take all of these numbers between -5 and +1 and map them over to some different range, let's say between 5 and 11. And that's going to be my output. So how can we do this? We want to create a relationship between this input and this output. So for instance, -5, if you give me the value -5 in, I will expect to get 5 out. If you give me +1, then I'll expect to get 11. And then for anything in between, I'll have just a linear mapping between this input and this output. Well, what does this mean? We can create a graph to create this relationship. Let's say we place our graph so that the input is along the x-axis and the output is along the y-axis. Now try to think ahead here as to what I'm going to be trying to do next. Again, I want to create a relationship between the input and the output. And as a matter of fact, if you look at the previous math VMKs that I've posted already, you should already know how to do this. Okay, let's take it to the next step. We're given these 2 points. We know that -5 has to give us 5 and +1 has to give us 11. Well, let's plot these points on our new graph here. -5 will give us 5, so on the input, if we go down to -5, then our output has to be +5. So we place this dot right here. We do the same thing with +1 and 11. So on the input, we go +1, and on the output, we go +11. We now have 2 points. Now, when I say relationship, what does that really mean? Well, relationship is just a fancy word for a line. And it depends on what kind of a relationship, but the one we're going to be discussing is a linear relationship. So because it's linear, it's a straight line. If we wanted to have a, for instance, parabolic relationship, then you would have some sort of parabola joining these 2 points. Or you could have a cubic or a spline or some other kind of relationship. But I'm not going to be talking about those in this video. So for now, let's just say we're going to be using a straight line linear relationship between here, this one point, and this other point up here. Okay, what do we need to do next? We want to figure out, for instance, if someone gives us the value of -2, let's say this value here, what should the output be? Well, it's actually quite obvious now. If we just look at the grid, we see that at -2, if we just travel straight up here, wherever the intersection is along this line, that's where the output should be. So we'll just move straight across, and we see that our output should be 11, 10, 9, 8. And the same thing for, let's say, 0. X equals 0 would be here. If we travel straight up, we notice that it crosses at 10. And if we count them out, we'll see that this is location of 10 on the y-axis. So that's what we're doing. We're giving an input, we're mapping it along this line and figuring out what the output is. So to do this, we need an equation for this line. And if you go back to one of the previous videos on equations of lines, you'll see that we can create an equation based on just 2 points or based on a point and a slope. The general equation of a line is y equals mx plus b. M being the slope and b being the y-intercept. So let's first go and solve this equation so we'll have something to work with. First thing we want to do is solve for m. Well, m is the slope of this line. And if you remember, the slope of the line is defined as rise divided by run. The rise of this line here is 10 minus 5. So that's what we have here, 10 minus 5. The run of this line would be 1 minus -5. And that's what we have here, 1 minus -5. So when we solve this, we get 11 minus 5 on top, so that's 6. And then 1 minus -5, which is also 6. So we get 6 over 6, which is equal to 1. So the slope of this line is equal to 1. So that's one parameter inside of our line equation that we solved for. Now we just need to solve for the value of b. We can rearrange our equation to be b equals y minus mx. So we take the mx part to the other side of the equation, and then we plug in some values. Well, I'm going to use this point here as one of my values that I plug in. Our y value at this point is equal to 5, so I plug that in. Our m value we solved up above here, so it's equal to 1, and our x value happens to be minus 5. So when we plug all these things in, we solve b equals to 10. And we can double check whether this is correct or not by looking at the y-intercept. And sure enough, at x equals to 0, we can count up. B has to equal 10 because that's where the line crosses the y-axis. That's a special parameter for b. B always tells you exactly where our line crosses the y-axis. Our final equation is y equals x plus 10. That tells us for any value of x, all we need to do is add 10 to it, and that's our value for y. So we can see here, for a value of minus 5, we add 10 to it, and we get plus 5. For the value of 1 for x, we just add 10 to it, and we get 11. If we take any other value, for instance, we take, let's say, minus 2. If we take minus 2, plug it into here, we get 8. And we can confirm that. Again, we'll go 1, 2 back. We'll go all the way up and then across, and we see we got 1, 2, 3, 4, 5, 6, 7, 8 divisions. So that's our value for y. So there you go. That's as easy as creating one relationship to another using a straight line. Okay, now let's take this example that we did here and write a general equation for what we're trying to do. Again, we'll have a relationship between the input and the output. We're given two different points. We'll label the first point here as having the coordinates ax and ay, and the second point here to have coordinates bx and by. So we have exactly the same thing we did before. Now we want to know the equation of this line, so we use the x value as the input and the y value as the output. And this gives y equals mx plus b. First thing we did is we solved for m. And we can get the solution for m because m represents the slope of this line. And the slope, once again, is rise divided by run. So the rise here is by minus ay, and the run is equal to bx minus ax. So that's that value. Then we went and solved for b. So we rearranged our equation, or our general equation, y equals mx plus b, to be equal to b equals y minus mx. And then we chose one point along this line, and I chose this bottom point here, so we're going to use this one again. Our y value at this bottom point is equal to ay, and we subtract m from this equation, and m up here was already solved, so we just plug that in, and then our x coordinate at this point is equal to ax. So here's our general solution for b. So now all we need to do is plug in m and b into y equals mx plus b, and we get the following. Y equals, there's the value for m, times x, plus, and then all of this is equal to b. So that's our general equation that we can use to solve any kind of relationship. All we need is these coordinates here that are along the line, and then for whatever value of x you give me, I can tell you exactly what the value is of y that's along this line. Now, one thing to be careful of, this equation is a general equation of a line. It has no start and stop. So if you gave me a value outside of this range here, let's say some value over here, this line would extend downward, and I would get the y coordinate that would be somewhere down here. Same thing if I give you a value of x beyond this point here, so maybe out here, I would have to get a solution from this equation that would be somewhere up here for the value of y. So just be aware that this is a general equation, and it's not constrained to be between the 2 points you gave in the solution for the equation for the line. Okay, now let's go and solve this general equation for two special cases. And these two special cases are used quite often in computer game programming. So let's go take a look at these. Okay, special case number 1. Again, we have the exact same drawing here that I showed you before. What we're doing here is we want to get a mapping for our range in x between 0 and 1. So in other words, our AY value is going to be equal to 0, and our BY value is going to be equal to 1. So we only are interested in getting an output between 0 and 1, and the input can be anything. So AX and BX can be absolutely anything, but everything we give it has to map between 0 and 1. So first thing we do is we get our general equation from this previous solution in the previous slide, and we just plug in the values. So if we plug in BY equal to 1 and AY equal to 0, we get the following. We can simplify this equation just by taking the x value and subtracting AY here, because both of these have the same denominator, and you get the following solution. Y is equal to x minus AX divided by BX minus AX. So in other words, any value you give me here, subtracted from this minimum value, divided by the range between the maximum and the minimum, gives me a ratio that happens to land between 0 and 1 for y. Give this a try. Okay, our second special case that we're going to discuss is the following. It's exactly the same thing as we had before, but this time the slope of the line is pointed downward rather than pointed upward. Again, we want to map between 0 and 1, but this time we want to define that the minimum input value is going to give us a maximum output value. So it's going to be equal to 1. And the maximum input value will give us a minimum output value. So here we have by equal to 0. Again, we redo the exact same thing we did before. We write our general equation, we substitute these two values into this equation, and we get the following. We can then simplify this equation by collecting everything here with the common denominator. So we get AX minus X all divided by BX minus AX, and then we have our plus 1 sitting outside. We can simplify this a little bit further because 1 is actually equivalent to BX minus AX divided by BX minus AX. This is equal to 1. But doing this gives us the same common denominator, which means we can then add the top parts together. When we do that, we get y equals bx minus x over bx minus ax. It looks very, very similar to what we had before. You notice that the x minus ax part here is just reversed. We have bx minus x. So if you're going from a downward slope, you want to use this equation. If you have an upward slope, you want to use the previous equation. So I hope this was helpful. And if you need to map one thing to another, just remember your general equation, which is shown here. Using any 2 points, you can define a straight line connecting those points, and then using this general equation, you can get any other value between these points to be linearly mapped for the output.